The first lecture we have today is going to be given by Professor Francis Bretherton, and we're extremely lucky to have him here today. He's recognized throughout the world for his contributions in the Earth system science studies, and he's responsible for creating the program that NASA is currently executing. The first launch of the Earth Observing System spacecraft, which is now renamed the Terra spacecraft, took place last December, and it is beginning to send some useful data. And we are very lucky to have him give us this first lecture on Earth as a system. And with that, I welcome Francis.
Okay. Thank you, Sanjay. I'm going to be giving this as mostly as a set of slides. You won't be able to see me while I'm doing that. You'll hear my voice. I can see you. So please, if you have a question or if you want to interrupt, just raise your hand so that I can see you. That's probably, and also speak, and that combination will probably get my attention, even though you won't be able to see me once I really start. As mentioned, this material is available on a website, both the images and a fairly extensive set of written notes. I'll be following that material fairly closely in my oral presentation, but let me check. Who has actually seen that material so far? Okay, 3 of you at 4 of you. Okay, most of you have. Well, for those of you who haven't, it is available on the web in full color, and that's basically what I'll be showing you today.
If you just pull us off the web?
I'm assuming that's what they got.
Yes.
Okay.
Do they know what the web address is? We'll give you the web address at the end. Okay, so I'm ready then, and I'm going to shut myself off this image and go. I thought, didn't get there, why not? Here we are. I've got to press that button. Got it. Sorry, it's still not second nature to press the right buttons. First question is, can you read what's on that screen? Who can't?
Yes.
Yes.
Okay, that's okay. Well, let me proceed. This lecture is about our environment and us. You, me, and people all around the world. And humans have always built their nests and family groups to protect their young, making houses to keep out the rain and the cold, and growing crops to provide food, exploiting animals for meat, clothing, and transport. We've learned to make tools to help these activities, and more recently, to mine coal and oil to provide power. We've also drawn on the rich diversity of nature, which we've found around us to further our own interests. Compared to other species, we have some great advantages. Through language and social learning, we can share experiences and knowledge, and we've established a dominant position on this planet. Yet, during our lifetime, there have emerged signs that we're fouling the nest, not just for ourselves, but for our children and grandchildren on a global scale. For the first time, we're not just spectators of the natural scene, but we're actively changing it in fundamental and irreversible ways. And we've little idea of what we're doing. We need to understand how things work. Otherwise, our future will be ruled by the law of unintended consequences. There are 6 major areas which have been identified as ways in which humans are affecting the environment on a global scale. The key points I want to make in this class will be delineated, and I've already got a problem right there because what came up wasn't what I expected. Just a second. Here we are. These key points will be reiterated throughout the lecture. The little flag up at the top is just to use to indicate which one is really we're paying current attention to. So I won't bother to read them all, except to remark that we are now, first of all, talking about the human activities that are affecting the environment on a global scale. The first you've heard about is burning fossil fuel, causing global warming, we think. The hard data on this is contained in this graph, which is that of carbon dioxide in the atmosphere. You see on this, if I can get my pointer to come up, yes, I can. You see that starting in the 1800s, at the beginning of the Industrial Revolution, the carbon dioxide started to rise and has been rising at an accelerating rate ever since. This rise is primarily due to the burning of coal and oil worldwide, which is injecting carbon dioxide into the atmosphere far faster than natural processes in the ocean or in the soil can assimilate it. Now, most knowledgeable scientists believe this is the reason the world is getting warmer by about 1 degree Fahrenheit or 0.6 degrees centigrade over the past 100 years, globally averaged. This may not seem very much, but the rate of increase has accelerated greatly over the past 3 decades, and projections indicate several degrees over this coming century. By contrast, during the last ice age, the world as a whole was only about 5 degrees Fahrenheit cooler than at present. Though here in Wisconsin, that was much more. Overall, the world during the ice age was much drier and dustier. The forests, lakes, and grasslands were all in different places, and it was a very different environment in which to live. Our future is not the ice age, of course, but the reverse. But however, global warming, with it, we should expect changes in the environment, which are of comparable magnitude to those that we saw in the last ice age to the present day. Much about our climate environment that we take for granted should thus be called in question. Another area in which we have been noticing our footprint on the world is the ozone hole. I'm sure you've heard about this. This picture is taken above the South Pole. The red in this graph actually indicates the ozone hole. It shows the greatly reduced ozone shield over Antarctica, surrounded by the green and orange that you see here over the ocean, which actually indicates somewhat above normal. This hole has appeared each spring, that's October and November in that part of the world, for the last 20 years, associated with the return of the sun after the polar night and the extreme cold temperatures special to that part of the world. There's also a much weaker hole occurs in the northern hemisphere over Wisconsin. Now, this ozone hole is often confused with global warming, but it's really a very different phenomenon. It's not due to the burning of carbon dioxide, but rather due to the escape into the atmosphere of chlorofluorocarbons, man-made. from refrigerators and air conditioners and spray cans. These inert molecules, they were a great invention in the 1930s. They have a lot of beautiful properties still. Unfortunately, they accumulate in the atmosphere and work their way up to the stratosphere, which is where the jet airplanes fly. Under certain conditions up there, they're broken apart by the ultraviolet radiation from the sun, and the chlorine so released destroys the layer of ozone, which protects us down here from that same ultraviolet radiation. Ultraviolet radiation causes skin cancer and cell damage to anything in direct sunlight, both humans and in plants and animals. And the ozone hole, of course, greatly increases the potential damage from that. However, spurred on by this dramatic evidence of the unexpected human impact on the environment, the industrialized nations agreed in the early 1990s first to limit the growth and then to eliminate the production entirely of CFCs by the year 2000. That, of course, is now past. The good news is that the chlorine loading of the atmosphere is already beginning to decline. We're seeing signs that the Montreal protocols actually are working. The bad news is that the ozone hole is likely to be with us for another 50 years or so. And meanwhile, the increasing carbon dioxide concentration in the atmosphere is likely to make the northern hemisphere problem more severe. A third example here is that of acid rain. This is, of course, primarily a regional problem, but is showing up on all the major continents of the world except perhaps Africa. It's due to emissions of sulfur dioxide and nitrogen oxides from coal-fired electric generating plants. These give rise to the acid rain, which corrodes stonework and automobile finishes. It kills the fish in lakes, which are not protected by alkaline soils, and contributes to forest dieback and loss of production. This picture shows a statue in Germany. On the left, you see the statue as it was in 1950. Here it is in 1990, and as you can see, there's not much left. Another major issue whoops, I've got into a mode I shouldn't have done. Just a second. I'm going to have to pull out of that. Here we are. Got it. Another major issue is that of fresh water. Now, this is something that is very important to all of us. However, as it's coming up in a later lecture on the hydrologic cycle, I will leave it for now and just pass on. In many parts, this picture is of degraded land around a waterhole in Africa, in the savannah. Here we are. This down here, this little animal is a cow feeding at what remains or drinking at what remains of the fresh water. You see, the grass for miles around this waterhole is all gone. It's been eaten by the cattle coming to the waterhole. This sort of degradation is happening all over the world. We also have, of course, extinctions going on, from large mammals to tiny insects. Species are becoming extinct at a rate which is unprecedented since the demise of the dinosaurs some 60 million years ago. Now, the cause is not a meteorite, which it was for dinosaurs, but instead the heavy footprint of a new dominant species on this planet, cutting down the forests, fracturing habitats into ever smaller pieces, and deliberately or unwittingly transporting alien species to every corner of the globe. Again, this topic will be taken up later. This is an endangered species, but just happens to be a friend of mine. Now, what are the impacts on human societies of all of this? The honest truth is we don't know very much. We can say a few things. What is clear as we come to grips with these changes, fundamental values and lifestyles about the way we live our everyday lives are going to be questioned. Second point we can be pretty sure of is there's a tremendous delayed reaction to our actions here. The fossil fuel that we burn now is with us for 100 years at least and accumulates. And things are only going to get a lot worse in this regard before they get better, whatever we do. Finally, the last point I would like to make is that remedial actions of any sort are likely to have indirect consequences that we haven't foreseen. The system is sufficiently complicated, we know that from experience, that it is highly likely that some things at least will happen that we didn't expect, and we've got to be prepared for them. The last key point is, of course, that in order to do anything about this, we need a basic scientific understanding of how the Earth functions. Not just the atmosphere or the ocean by itself, but how it works as a complete interacting system. And that's what I want to talk about for the rest of this lecture. In particular, we need to understand, first of all, be able to distinguish the natural variability of the system from what is human-induced. We simply mustn't blame everything on global warming. It isn't. Illustration of this is this map, which is taken of the Ice Age 18,000 years ago, when the ice was at its peak, and of course, here it is somewhere, here it is. And of course, there was a tongue of ice extending southwards over Wisconsin at that time. And that was several thousand feet thick. Now, we think we know what caused these ice ages, and that is recurring changes in the orbit of the Earth around the Sun that take tens of thousands of years to unfold. Following one of those changes, about 12,000 years ago, all this ice melted. And since then, the world as a whole has been unusually warm compared to most of the past million years. During the Ice Age, as I already mentioned, the atmosphere was already much dustier, and the grasslands, forests, and deserts in quite different places. And the whole Earth as a whole was about 2 to 4 degrees centigrade cooler than at present. This is why we lay stress on the changes that have taken place since the last Ice Age, because of course they're not a perfect analog, but at least they give us some idea of what the next century may hold for us. Now we can see what's going on in the Ice Age, or the evidence of the past Ice Age, I beg your pardon, by looking around us. This picture here, and I'm sorry if I can get it to, if you press on it in the website, you can get it to enlarge so that you can see the whole text. Let me see if that'll actually work. No, it probably won't. But we see at the back here a retreating glacier, and we see features such as this end moraine here, which is debris built of debris which were carried by that glacier and dropped at the end of its flow. Madison, city of Madison, is built on exactly such a moraine. The hills around here are also full of what are called kettle holes, which are hollows in the soil that formed when large blocks of ice essentially got trapped and buried along with the debris. And eventually, when that ice melted, the land collapsed and it fills with groundwater. You can see kettle holes, distinguish them, because there's no stream that exits from them, even though there's water accumulates at the bottom. Moving on, we also have to understand the interactions between the ocean and the atmosphere and the rest of the system. This image is of El Nino, the temperature across the equatorial Pacific from about 20 north to 20 south. The red, of course, means that's warmer. A normal picture in the middle, as you saw in December 1990, the December 97 was a lot warmer, particularly in the eastern half of the ocean. That had a lot of consequences, in particular on the fish in that part of the world and the weather systems, not only there, but also all over the world. Since 1998, we have been in the opposite phase called La Nina, which is actually unduly cold in that part of the ocean. We get this information in part from satellites and in part from buoys like this, floating in the surface of the ocean, and with equipment that measures the temperature subsurface for several hundred meters down below. Now, this has an effect, El Nino has an effect all around the world. Scientists, just in the last decade, are we losing one site? Shall I continue?
Yeah, go ahead, continue.
Okay. During the last decade, scientists have been learning more about these effects of El Nino. The upper image here shows a portion of southern Africa. This is data on the amount of green vegetation. It's obtained, in fact, from sensors on the meteorological satellites put up to observe the weather that by chance are able to give this amount of greenness routinely. And you see that during an El Nino period, there is a whole area across southern Africa that is very dry. The red here is indicating stress on the vegetation. During the La Nina, on the other hand, it does very well. And this data is actually being used now by relief agencies around the world to tell them when to expect a famine. And given this type of information, they're already taking precautionary actions against famine several months ahead by moving stocks of food and that type of thing around the world. We also have to look at evidence from the past. We've already looked at some features of the Ice Age, but here's another picture, another piece of evidence we have. This picture here is of a cliff in Peru on the edge of an ice sheet. Did you know there were ice sheets in the tropics? I didn't, but this is one. What we see here, if you look very carefully, you can see some layers in that ice, which is the snowfall each year being marked right in the way it melts at the edge. Now, those layers are very useful, just like tree rings. They enable scientists to work down from the top and give a precise date to every piece of ice in that ice sheet. And by sampling the air bubbles that are trapped in that ice, we can discover what the carbon dioxide was and what the composition, the dust was in the air at that time. That's how we know about the dustiness. You can also look at chemicals that are in the water in the ice, in the oxygen isotope ratio, and get an estimate of the temperature. That's how we get that sort of data. This is the surroundings to that ice cap. This dome, pale white dome you see, is actually the ice cap. We were looking at just its very edge. These are llamas in the foreground. As you can see, it's pretty high in the Andes, but it's pretty barren. But that's the sort of thing, that place in which we get good data. We also have to document the effects of what we are doing to the environment reliably. This picture here is just simply of a pipeline in British Columbia. A spill, an oil spill from that pipeline would give rise to an ecological disaster over that area. But too often, all we do is we take the measurements after the spill. And we have no way of knowing what the situation was really like beforehand. We have to be watching and looking ahead of time in a precautionary way all around the world at what's happening. Otherwise, we'll be taken by surprise. Finally, we need to simulate future changes and assess their probable consequences. There's been a group of scientists known as the Intergovernmental Panel on Climate Change that for the last 10 years, every 5 years, actually a little more often, has been putting out reports like this one, simply assessing what is known on a regular basis, forming consensus judgments about what is known and what is still controversial, and what we need in the way of better information. These consensus judgments were the underpinning of the commitments to reduce future emissions of greenhouse gases that were made in Kyoto in 1997 by the most developed nations of the world. This picture here is simply one of projections for the next 100 years of a number of different scenarios for how the nations of the world might control their emissions. The upper one of these curves, the top one, is business as usual. What will happen to the global average temperature if we do nothing? Notice on this projection, it rises 2.5 degrees by the end of the century. Even with a very stringent emissions reduction scenario, we still only cut that in half. And the most ones that are being seriously talked about are only making a 5–10% reduction in the warming that we should expect over the next 100 years. There's a moral to this story. Now, this scenario, I should add, may be wrong. It may be too large if the climate sensitivity, that's the sensitivity of the system to carbon dioxide, turns out to be lower than we think it is. That's beginning to look very unlikely with what we've been seeing over the last couple of decades in terms of global warming. On the other hand, it also may be wrong in the other direction. There may be feedbacks in here and sensitivities that have not been taken into account. And as a result of that, the warming may be more than 2.5 degrees over the next century. In any case, it would appear prudent to plan for ongoing warming throughout our lifetimes and focus on ways of adjusting to its effect and minimizing their impact. To sum up, human activities are affecting the environment on a global scale. The impacts of human societies are potentially substantial, but largely unknown in detail. We know qualitatively what happened, but in specific places, specific locations, it's very hard to make good predictions still. Finally, we need better information. We need a basic scientific understanding of how the Earth functions as an interacting system. And there are just some of the sources of information that I've been using. There are more details on this, of course, on various websites. I mean, on the website itself, and a lot of other links on that one. So that's the end of the lecture, and I'd like now to open it up to questions from you. Who wants to go first? Or comments, for that matter.
I have a question.
Yes, go ahead.
In the satellite photos showing El Nino and La Nina,
Yes?
what are the different variations in the temperatures between those two, and how far down do they go? Do you know?
Yes, maybe I should try and get back to that picture.
Okay.
No, I won't. I'll deal with it without.
Okay.
We see me wave my hands in that case, which is a real part of the live show. No, the temperatures are about plus or minus 2 degrees centigrade. Now, the last El Nino was a particularly intense one, and it was actually up to about 3 or 4 degrees warmer than usual in the eastern half of the ocean. They go down about 200 meters, 700 feet. That's not a lot compared to the depth of the ocean, which is 5 kilometers. But nevertheless, it is the part that is routinely warmed by the sun and by the atmosphere on top. And a La Nina phase, what happens is that warm layer is much shallower, and it only goes down 50 meters, and the surface temperature gets reduced by a couple of degrees in the process.
Thank you.
I just have a request, at least initially until we get very familiar with your names, if you could identify yourself when you ask the question, I think it'll help us a little bit. Was that you, John, this year, or?
No, my name's Jim. Jim Nolan from Merrill.
Okay, thanks
Thanks.
very much.
Thank you.
Now, some other questions.
This is Rob, MHLT.
Yep.
I was listening to public radio, and I'm sorry I can't quote who was saying this, but the idea was that the American society, we're basically in adolescence, and in part of adolescence maybe is a sense of wonder and curiosity, but also a sense of recklessness and really not thinking about consequences. What is your perception of our state of denial in this crisis?
The short answer, pretty deep. I wish I could be more optimistic about it. In fact, deep down, I am optimistic. Deep down, I think human beings do have good judgment, and we do tend to use it. It's mostly a function of what we know. And that's really where little episodes like this become very important, because we have to learn to communicate to that public, particularly to the children, what's at stake here. It's really their futures. For me, I'll be long gone before these consequences really come. But for them and for their children, it's their future. And we owe it to them, I think, to help them understand these things. If that happens, I'm really quite optimistic that we'll be ingenious enough to find ways of dealing with it, even if we can't stop it.
Thank you for your insights. I appreciate that.
I just had a comment on it. I think last week or this weekend, we had the Berkey Biner race canceled. As you know, that's a fairly intense experience for about 6,000 people. I think it attracts skiers from Europe. There are quite a few from Scandinavia, France, Germany. And I just wanted to comment that if indeed the cancellation of the Berkey Biner race, which I know is a single event, is due to the global warming, then essentially it points to certain fundamental changes in terms of what the state's economy, at least the winter economy, is likely to face in the future. Because I think for that one town, Cable and Hayward, I think it was a fairly extensive impact, economic impact. And I think these are the small issues, local issues, that in a sense, taken globally, really make the impact of global warming somewhat more close to home.
That's, of course, very true. Now, we also have to remind ourselves that we've always known there are cold winters and warm winters, and they tend to alternate or, let's say, recur fairly randomly. Here in Madison, we're noting, for example, that the lake is ice-free. It didn't freeze this year until the 20th of January. That is a record by a long way. However, the previous shortest ice-free region in the last 100 years was only 2 years ago. Now, that's not conclusive proof of global warming, but the more of those episodes you have, they add up and they give reality to what our global measurements tell us is really happening.
Any other questions on the topic from either side?
What about the technology?
I guess this is Tom from NTC. My question or comment is that takeover of the paper mill in Wisconsin Rapids has become a fairly hot topic, and the idea of the global manufacturing process and the competition of third world nations producing paper and products with virtually no restrictions on emissions, pollution, etc. What's the effect of the third world nations going to be as their economy increases in terms of this global warming?
That, of course, is one of the fundamental political issues. The Framework Convention on Climate Change, which was first agreed to in Rio de Janeiro in 1992, I think.
Right, yeah.
As one of its meetings was in Kyoto just over 2 years ago. And that was the first time that any of the nations of the world have ever actually agreed to try and limit emissions. Now, significantly, the nations that signed the Kyoto Protocol were only the developed nations of the world. And at this point in time, I think anyone who's looked at it would say that is fair. Trying to put some numbers into it, the emissions of carbon dioxide into the atmosphere from burning fossil fuel are about 5 billion tons or 6 billion tons a year. That's almost exactly an average of 1 ton for every person in the world, every 1 ton a year of carbon. Here in North America, our average is 6 tons of carbon per year. If you go to Europe or Japan, it's about 3 or 2. We are, in fact, by far the most profligate of the societies around the world in terms of our energy use. If you go to the typical developing country, they are at this moment only accounting for about 10%, 20% of the total emissions. They, politically, regard this as a problem for the developed world. They say their priority is to raise their standards of living to get close to ours. And we made the problem, so we better fix it. And that equity argument, frankly, carries a certain amount of weight. The catch in it is that when you extrapolate forward their rates of development, particularly in Asia, where most of the population of the world lives, you find that by about 2030, the emissions from them will exceed those from all the developed countries, currently developed countries. And the big political problem is how to get the developing nations to sign on so that we don't simply just remain in a highly competitive situation in which everyone looks out for themselves and no one looks out for the world as a whole. That's the problem. And the Kyoto Agreement was a conscious attempt by the developed countries to try and put their house in order to build the case that as the developing countries increase their size of their economies, they should do it in a more fuel efficient manner and not, in effect, make the problem worse than they otherwise would. But this is another reason why it is certainly going to get worse before it gets better.
I just have a question for the Minocqua site.
We
Seem to be losing picture again. Can you hear us? In Minocqua?
No.
Playing.
Hear you.
Can you hear us?
Can you see them in? Oh, we're back now.
Yeah, I guess
Hello?
we're back.
Hello.
How much of that did you miss?
We're here.
Okay, okay.
Could you hear us throughout?
Yes.
Oh,
Okay.
we just couldn't see you. Or hear you. That was what was happening.
Okay.
Sorry, it's hard to work out. One of the nice things about your picture, you have a screen in the back of your room which actually duplicates the 4 I'm looking at here, so I can see whether you're seeing us.
Right.
Other questions, comments?
If not, I have a question. How many of you saw the story in this morning's New York Times about global warming? Did anyone see that story? I guess not. If you, I'm not sure if you folks have a copy of the Times or have access to it or not. New York Times, the Science Times section on Tuesdays usually carries some topical science stories. And this morning, while I was thinking about this lecture, I looked at the paper and the story was about global warming. And I just wanted to bring it up for discussion because we appear to have some time, and I wanted to bring in some aspects of observations and also technology. The debate seems to be the global warming, is it real or not, and how do we know if it's here? And I guess I'd like to encourage the teachers to express their views on it or any questions about it before we have Francis answer it. I guess one of my reasons for doing it is that we try to pick these topics and try to relate them to the science standards. And I think Rosalind will tell us more about the science standards. And unfortunately, we don't have any idea yet as to what grade levels you are teaching. But I'm just wondering whether these issues are mentioned in your curriculum that you teach in your schools. I think as we go on, as we learn more about you, then this process will work better because then we can deliver the kind of content that you folks are looking for. So I'd like to invite all of you to just comment on the issue of whether you think whether the global warming is real, or if you have any personal opinion about it. It doesn't have to be necessarily an informed opinion, but just your gut feeling. Feel free to answer it. Don't be shy.
This is Tom and Merrill.
Mm-hmm.
And personally, I think that global warming is a real issue, and it's something that we need to consider as an important issue in the coming years. I know that I've talked about it several times already in my classroom this year, and continue as I find information to put it out before the students so that they can try and become educated. I think things like we're doing here, the technology that we're using, the ability to interact is great. Mm-hmm. And I think for us to be able to bring in experts into our classrooms to let those students hear from another source would be a real asset.
Other comments? Yes, go ahead.
This is Jim from Merrill. I teach 8th grade earth science, and we do talk about this. In fact, we talked about coal burning last week. Most of the students were very unaware that about half of our electricity is from coal, and other fossil fuels. That was something they weren't aware of. Global warming, I have a question that maybe the professor can answer. This does come up in the class when we talk about global warming, and I have some questions myself. How long have we been looking at the data? How far back does it go? How far back is it reliable as far as the amount of CO2 in the air and the temperatures of the globe? Do you have any data on that, or
Yes.
can you share that with me?
I'm not sure I've got the graphs here, but in terms of instrumental records, that's people with thermometers around the world, they go back usefully about 150 years to about 1850. And over the last 100 years, there have been enough of them so that we've really got a fairly good idea. Over the last 50 years, we've got a very good idea of what the surface temperature has been doing. And it is going up and going up fairly fast, particularly over the last 2 decades. We, however, can get backwards longer than that by looking at the ice cores. This is why I showed you that picture of how it's done. What I call the isotopes of oxygen, the fact that normal oxygen has weight 16, the atom. There is another form of oxygen that has weight 18. And the ratio, it's a lot less than the 16. But the amount of 18 relative to 16 there is in water, in ice, is a measure of the temperature at which that ice was laid down. And from that, we can look back hundreds of thousands of years. We see these alternations of ice ages and relatively warm periods. Long before humans started messing things up, we have been in a warm period. But what's happening now is we're accelerating beyond what we would have seen, what the world has seen in the last few 100,000 years, in ways that we haven't really come to grips with yet. So in that sense, it does seem to be real. Now, one thing we can't be sure about at this time, unequivocally, that what the warming we're seeing is entirely due to human activities. Some of it may just be a natural fluctuation, like some of those that have occurred in the past. We don't think so because we don't know what would be causing it. And we do know that the burning of fossil fuel ought to be causing it. And from the people who've really looked at this closely, the balance of evidence, there's a consensus among them that the balance of evidence says that in part at least, the global warming we're seeing now is due to human activities. The longer it goes on, the more likely that will be.
I just want to add a quick note to that as to why that last assertion is particularly significant. And I don't know if any of you are folks of science fiction movies, but if you go back about 30 years, there were some movies made. This was just at the beginning of the space exploration era. About a movie that I know where people were going to Venus and live on it. And if you read some of the scientific, I don't mean the scientific, I mean science fiction, our notion of Venus was quite different. If you think back 30, 40 years ago, people thought there were forests, there were wonderful female species, and all sorts of fanciful imagination. Unfortunately, those hopes were dashed in the 70s when it turned out that some of the radio measurements indicated that Venus, despite being considered Earth's twin, about the same size, with an atmosphere, is extremely hot. It's extremely hostile at the surface. And people have been wondering, I think most notably Carl Sagan raised the issue and suggested that this was a runaway greenhouse effect. And I think that's the reason why some of the scientists are so worried about the global warming, is that if a planet like Venus, where you can take an Earth-like planet and an atmosphere and turn it into a hothouse where the surface temperature is 950 degrees Fahrenheit, could that be the Earth's fate in the near future? We know in the long run that is going to be our future, or rather the Earth's future, but that's a long, long time away. That's, I mean, it's tied to the history of the sun, the solar revolution. But in the short run, is this global warming going to continue? The reason being that if the carbon dioxide raises the temperature, then that raises the temperature to such a high degree that it releases more carbon dioxide from carbonates. That increases the warming. And it's basically a process that you can't stop. At least that's how we think Venus got that hot today. Now, exactly when it happened, we don't know yet. But that's the area of space exploration. People would love to go to Venus and take rock samples and find out exactly when that warming took place and what was Venus's early history. And the difference between the evolution histories of the Earth and Venus, when did they diverge? Indeed, why isn't Venus habitable now? But John, John, right? In the back, you had a question. I'm sorry, I went on rambling there a little bit.
No, that's okay. I just wanted to ask the professor, would it be accurate that if we were looking at the rate that the temperature is rising now, that it is going at a faster rate than we would think if nature was causing it?
Yes.
Based on the ice core samples, right?
But one of the things that it's hard to give that definitive answer to that is over the last 1,000 years, the ice cores they provide a record, but it's only of certain special places in the world. We can also look at tree rings in places like North America and work out from their growth rates. There is what's been happening. There's a lot of research going on looking at coral reefs, which again have annual cycles, and you can use oxygen isotope ratios for that to build records back for the last 100 years or so. Now, each one of those have to be calibrated a little bit, and there's some uncertainty about that process, and it's down at the sort of 0.5 degree, 1 degree level, which is such that if you're just looking at 30, 40 years, we're not sure we can get the estimates of a growth rate that accurately, for sure. But it is beginning to look as if what we've seen for the last 30 years is certainly in the 5 percentile of probability of having occurred in the last 1,000 years. Maybe even more extreme than that. In other words, it's something a statistician would call very significant. But the jury's not entirely in on that question at this moment.
Thank you.